Hey, this is Professor Snell from E231. I am going to make a video of the workflow I did to create the Excel outputs for the stress strain diagram. The idea here, this is going to be somewhat long because I'm going to go through it in some detail. People are struggling with different parts of this. Some people have never used Excel, so you can just scroll to the part of the video that you need and then work through it slowly. That's the idea. Okay, this is what we're heading toward. How did I get there? First of all, here's my raw data as it came in from SparkView. I've already saved this as an XLSX file, a workbook file in Excel. If you get data from SparkView, it's true of other things like LabVIEW, it's often a text file. Remember that that's just text. So if you're opening Excel and you do a bunch of cool graphics or charts and graphs and save it as a CSV, you'll lose all that work. So make sure you save it as a workbook. So now I have my raw data. I've already named this raw data, but it would say sheet 1 probably for you. Just make sure you, when you bring your data in to Excel, name the sheet raw data or whatever you want to name it. But here's the point. I'm going to now come in and protect this sheet. So I right-clicked on the sheet name, protect it, select lock cells, select unlock cells. I like that. This now I can't change anything in here. If I click on a cell, it says you can't do that. So now my raw data is protected. I can do whatever I want to with another copy of the data because it's just for analysis. If I change raw data, that's cheating or maybe even illegal. If I have raw data and then I have another copy of it and use it for analysis, that's completely fine. So just understand the distinction. I'm going to move or copy this one sheet. I'm going to create a copy, say OK. Now I have 2 copies of this. I'm going to right-click on the copy I made and unprotect it so that I can do whatever I want to with it. I'm going to change the name of it to analysis. So now I have a copy of the data that I can do what I like with. The first thing you do is make sure you can see everything. I think this came in and it looked like this because I played with it for a second before I started the video. Make sure that you can see the first thing, that you can just understand what data you've got. So spread it out. Make sure you can read out everything. And I would always just plot things first off the bat. So let's look at Excel quickly just to understand how it's laid out. We have these tabs at the top. If I click on them, of course, what's available changes. Excel is organized into these little groupings separated by lines. So I have my clipboard over here, copy paste stuff. This is a color, text and cell color borders section. So it's a sort of a layout or a visuals section. Here's alignment of my cells. Here's the number, how the numbers are displayed. General is the default. You almost never want to have general, so you should understand how this works. Anyway, that's how Excel is laid out. I'm going to now insert a chart, but first I'm going to, before I lay out my data, I'm actually going to adjust this. I know already for stress strain I don't need date and time. I'm going to delete that column. I know I don't need time. It's unrelated to stress and strain, and I don't need speed. So I've got the data that I'm going to use. I'm going to create a little space around it by inserting columns, rows and columns. This is just something that I do so it doesn't look like the data is the entire universe. And now I'm going to select these 2 columns, come to insert, and insert a chart. So I'm over here in this chart section. I'm going to insert a scatter plot. Let's look at the differences here. If I have just the data points, the data points are very congested. If I do data points and curves, it's also not very clear, but I think this is the clearest way of laying this data out, so that's what I'm going to choose. But the point here is I can see that there's something funky about this data, though it does have the general shape of this. I have not applied any equations yet, but since the equations are multiplication and division, or actually both are division, the shape should be related to my stress strain diagram, and it turns out this is, but I can see that it's upside down. So how I'm going to fix that, and by the way, I can quickly create a scatter plot chart if I'm only using one data set by selecting the two columns. That only works if they're in the correct order. In other words, left is X, right is Y. That's just a protocol. Typically, when you have multi-series plots, you're going to have to individually input your data sets, and I'll do that in a minute. Okay, so also notice that that my data is in inches and pounds, foot-pounds actually. That SparkView's wrong. Foot-pounds are weight, that's a load, and pounds are a mass. So anyway, but on the surface of the planet, they're both the same. Planet Earth are the same, conveniently. Anyway, so I've already I set up my SparkView to give the units that I needed. If you came out in meters and newtons, you're going to have to do conversions. You could do that right now with this method, copy paste. Copy paste is not the best for most things because you don't have a record of it once you've done it, and generally we want to see what we've done to our data. I always want to see your calculations. The initial conversion, usually I'll be fine with you doing it like this. And I don't need to convert, so I'm just going to flip the orientation of my data. So I've got -1 in this cell. I'm going to hit Control-C to copy it. I'm going to select these two columns and come to Paste Special. Paste Special just says, okay, what do you want to do to this data you just selected, and what do you want to do with the thing that you copied to this data? I want to multiply my data by the thing I copied, the -1. I say OK, and it's going to flip the data. All right, so that's where I want to start with my data. I've looked at it, I've cleaned it up, and I've got it laid out. I've determined that it seems accurate, or it seems like that the experiment worked correctly. So I'm going to delete this chart. I'm going to delete these guys. I'm not sure how those zeros got in there. I'm going to delete that. Let me see something here. Okay, I just paused to check something out. I got an error message. And this is a great example. So what happened is that when I put in that, remember when I created the chart, I just selected both of these columns. Oh, actually, when I did the paste special, so it added these zeros up here. So there's formatting in these cells. So I'm just deleting that. And if I now try to add a column or a row, it's saying to me that it can't do that because there's formatting in these cells, and it's going to push that formatting out of the spreadsheet. Anyway, you don't need to understand it directly. Just saying that. You know, if you're watching a video like this, you can't memorize what I'm doing. What you're doing is understanding the workflow for this program, and then you have to just spend time in it. There's always little things you have to learn, and you're always going to forget them and relearn them, and there's a new situation, some little thing you haven't done before. So, you know, use your intelligence with this. Don't get frustrated, and you know, you'll be fine. If you go running for help every second something goes wrong, you'll never learn these things. Believe me, I've done that many times. Okay, so what I'm going to do then is I'm actually going to delete. I think what's going to fix this is if I just delete these columns first. It had the oops, I didn't delete it. I inserted. Okay, now I should be able to insert. Yeah, so anyway, okay, now we're back to this. The next step is going to be, let's go back and look at our output over here. You know, as you move forward with Excel, and of course you can do whatever you want to. In my classes, I'm going to always require that you lay things out something like this, because I'm trying to get you to use Excel as not only an output tool, but a tool to help you organize your experiments and your work. So I always want to see all your terms defined, even if it's obvious it's something we've already used. Everyone knows what stress and strain is or whatever. Define them, And this is also so that this is like your outline. You can go, okay, what am I doing in this assignment? You can start. You can add to this as you go. So you're like, oh yeah, I'm going to need to define that. Oh yeah, here's elastic region. I hadn't put that in there yet. So we're going to have a term section. Then there's going to be these published specs that we get from somewhere, and then some of it's calculating. And then we're going to do our experiment, or get the outputs from our experiment, and then we're doing some kind of analysis. We have our data displayed here, and then also data displayed as somehow graphically. That's basically what we're going to usually do. So how do I get this initial layout here of these terms? So if I come back to my spreadsheet, I need to add some more columns over here. I can always delete and add more, so I'm just going to add a couple more, just why not? And let's see, how did I lay this out here? Okay. I'm going to, I don't need that this is a run anymore. I'm going to delete that. I'm going to create a section right here called, okay, so I'm going to create a little header here. To do that, I'm going to merge and center. So I'm just selecting these two cells, hitting merge and center. Now they're combined. I can type in here terms, make it bold. What was the first one? Was axial load. I'm going to name it P. I'm going to adjust the size so that that it's where I want it to be. And then I can just keep doing that. So I'm actually going to come. I mean, you get the idea. I'm going to come just copy all of these. So I'm going to copy this first portion of this. Copy, paste. There it is. I'm going to adjust the size of it. So let's look at anything in here that's not clear so far. First, let me get rid of this border and re-add it. So if I want to do, and I just, why not start laying things out as I go? If I select all these, I can come up to my borders section, add all the borders. That this sort of outlines my data, separates it from the empty space. I can come up and add a thicker outside border. You have to set presets how you like them for this. I've already done it, so I don't need to change anything. There's that look I have from the other, from the final output. I'm going to get rid of that right now, just so we have room to play. Anyway, so what else do I have here? I have some special characters like delta L. How do I get that? I'm just going to add it to another cell. If I come up here to insert, in my world here, I have symbol way on the far right. I don't know where it's going to be in yours, but look for symbol. What that does is just gives you access to a bunch of languages. I've been using Greek a lot, I guess, in my Excel, so it's already goes to Greek and Coptic. I already have my delta down here that I can choose because these are the ones I've recently chosen. But just realize you have different languages. So if you were in Latin, you have to go find Greek and Coptic, or you can. There's probably a place that you can search for it. It's different for different versions of Excel. So anyway, all I have to do now is select delta, insert it, and there it is. Close this out. L. That's how I got delta L. How did I get my lowercase LW? If I say LW, I come over here to my font section, open it up. There is a subscript, but I haven't chosen the W yet, so I'm going to make this a subscript. Okay, so that's those two. Here's some more special symbols. How did I make this a color? Well, I just select a cell, come up to my font section, and make it whatever color I want. Okay, so that pretty well covers how I got the look of that portion. What else do I have over here? Okay, I have my published specs. Let's look at what we have here, and then we'll just repeat it on the other in the thing we're working on. Okay, first, what are we talking about? Well, we we know this is a brass 360. How do we know that? Well, we look at the place we got the material. So this is a link that I put in here. I'll show you how to do that in a second. And here's the link. I always want you guys to do this in these assignments. You need to be, don't take my word for it. I'm going to make mistakes. And just don't get in the habit of, you want to, it's what the company says this material is, not what somebody else says it is. That's where I got it in the first place. So this is the web page for these brass tensile samples from Pasco, which is where we bought them from. You can see that's what we used. If I come in here to specifications, this is where I got all the published specs. Tensile strength, I had to convert it from megapascals to psi. Young's modulus is modulus of elasticity. I converted that also. I converted the diameter to inches, so 3.33 millimeters. The working length is LW. Okay, so that's where I got that from. How did I get that? How did I put that in here? If I come back to here and I say, here's my merge and center. Go ahead and bold and capitalize publish specs. I say it's material. This is 360, brass 360. And source. If I now come back to this website, select the link, Control C it, I'm going to get rid of it, come into this text, select it, go to Insert, actually, don't select the text, just select the cell, go to Insert, Link, copy and paste the link and the address. The link is there now. If I click on it, it opened that up on my other screen. By the way, when I'm pulling stuff in, I have two screens, and that's why you'll see me things just showing up like that. Okay. So what else then? What do we get from? Let me open that up again. Well, we saw it already. That I came to these specifications and I converted inches to millimeters to inches. This, it's probably smarter to go ahead to do the full conversion to convert in Excel. But if you're just doing an initial, from meters to inches or whatever, it's okay to do that outside of Excel, I guess. That's what I did here anyway. I did a conversion. It's 0.131 inches. So I'm going to say D. I've already called diameter up here, right? So I can. The whole point of this is now once I get all these definitions, I can use the shortened version as I move forward. I'm always going to use my units. D in inches equals 0.131. I want to name this because I may use this for other things. So I'm going to turn this into a constant. I'm going to do that by right-clicking on this cell, going to define name, and I'm just going to call it D and say OK. Now, if I want to make my area in inches squared, because this is what I actually need, right? If I didn't want to do the carrot top, if I wanted to make this a little fancier, I can also do a superscript, right? So, this is our first equation that we're going to be inputting. In Excel, equations are always, you start with an equals, sort of obviously, but that's something you can forget. And the area of a circle using diameter is pi. So I'm going to, in this class, you can just put in 3.14 if you want to. That's accurate enough for what we're doing. Structural engineering, it's not, chemistry. Okay, anyway, but if I start typing in, if I'm looking for a formula, I can just start typing in a name. I get to pi, I can double click on pi. The formatting in Excel for pi is the formula that you input plus closing the parentheses. You just have to know that. If you don't do that correctly, it's gonna you're gonna get an error, and you're gonna wonder why. It seems obvious. You need to look things up. Anyway, so it's pi asterisk for times d. If I type in d, here's d shows up. I double click it. Then now that is actually, you can see that is this cell. I'm going to caret top 2, so that's squared divided by 4. That's my my area. And this is what I'm going to need for, the reason I'm doing this is because I need it to get from force to stress, right? Stress is force or load divided by area. But right now, this is too many. I don't need all these decimal points. Why are there so many decimal points? It's because I've got the general, the default display for this this data. So I'm going to come up here and select number, and now I can choose the number of. So maybe that's enough, 0.013. Now that's actually not changing the number of decimal points. Another way I can do that is come out here and say number, and I can change the decimal points here. I can add a comma separator, and I can do that. I can select a bunch of data and do that all at once. It doesn't change what's in Excel as far as the data. You still have all those that accuracy of decimal points, but it's just what you're displaying. So it's important that you display something that makes sense, that fits the rationale of how accurate you're being. Okay. So now we have an equation that we can use for changing force to stress. But let's go ahead and fill in the rest of this, the specs we need before doing that. I need the working length. If I can just come copy that now if I've got some special formatting that I don't want to have to repeat. I didn't copy it for some reason. I'm not sure why, so I'll just do it again. Subscript. That's kind of weird, but I don't feel like trying to figure out why. All right, the second. And that is, what is that? Let's go back up to our specs. Okay, so our spec says that the working length is 3.2 centimeters. If I'm lazy, I can just go centimeters to inches. 3.2. It's 1.26, right? So I can put in 1.26 without, again, that's kind of a level of calculation outside of Excel that I'll accept. We need, what else do we need to do? We've got, so the axial load's what's coming in from, so that's this. And actually I can even just change this to load, because that's what it is in our case. Cross-sectional area, we've just calculated. Displacement is, so I'm going to change linear position to displacement, because that's what it is for us. Working length we just did. Diameter we've got. Stress we're going to calculate. Strain, we only need the change length with this displacement divided by the working length. We've got that. Elastic region we're going to calculate. Modulus elasticity we're going to, well, we do have a spec for that. So E published is what? Young's modulus is the same thing, 80 gigapascals. G Pascal to psi, 80. So that's 1.16. So that's 11.6 million. If I want to display this as scientific, I come up here and select scientific. I have one too many zeros. Okay. what else do we need? Um, we don't need the published yield strength. We're going to just use the one that we get from the graph. Ultimate tensile strength, we want to, because we're going to compare that to what we get in our experiment. So again, that's back to our data, which is where it's here. Ultimate tensile strength is 500 megapascals. So 72,518.9. That's 72.5 KSI. So 1,000 PSI. So I'm going to use those units here. So 72.5 KSI. Stretch it factor we're gonna figure out from the data. So I think we've got all the published specs we need. So we can actually then add in our oops, didn't mean to do that. Let's make sure that's what I called it over here. No, experimental. All right, that makes more sense anyway. Okay. But so now we're at a point. Let me just change this to. Let me get say no border. Okay. Oh, no fill. Okay. Just cleaning this up a little bit as I go. I guess I'll leave that for now because we're going to have more here before I name this data. So we're going to have strain in inches per inch. Now, this is important. A few people made the mistake of converting this to percent. It's not a percentage. You can display it as a percentage, but it's a ratio. And if you multiply it times 100, you're actually changing the data, right? So don't do that. And I'll show you that in a minute or in several minutes. And then stress is P over A. And you can see now, since we've done all this definition, it makes it much easier to actually deal with our data, and we're comfortable because we've already defined this and we're thinking about what we're doing. So now I'm going to input my strain equation, which is going to be equals the displacement divided by the. Oh wait, one thing I want to do before I go on is I want to give these things names also. So I'm going to call this area. So right-clicking, defining name. I'm going to call it A. I want to call this sort of obviously. I'm going to call it LW. And I'm going to call this E. I'm not sure if we're going to need the E. I can't remember right off the bat. Okay, anyway. And if I ever want to see what I've named and make changes to it, if I go to formulas up here, name manager, these are what I've named. I can edit them. Okay, that's the only. You have to know where that is, or it gets frustrating. Because if you name something and you want to use that name or change it, this is a place to do it. Okay, so I'm going to input my strain formula, which is equals change in length divided by LW. This pops up because I just typed it in to access the formula or the constant. I can see now it's highlighting this cell, so now I'm right. Double click on it, and now I have F5 divided by the working length. If I pull down on this corner of the cell, I can apply that to all my data. I'm going to go ahead. I mean, we don't need all the zeros clearly, so I think I'll just stop at least there. We're going to get rid of some of this data anyway. Okay, now I'm going to do my stress calculation, which is the load, P, axial load is P, divided by the area, right? Pull that down. And now I've got my stress versus strain. Okay, now I'm ready to get started displaying some data to see where we're at. But before I do that, I noticed something when I was scrolling down here before that I didn't like. All these zeros. I think these showed up because maybe when I did the times minus one pay special, and I did the shortcut of selecting the full column or something like that. Whatever. That's a bunch of extra data. I think it goes to like a million rows. So I want to get rid of that. So I'm just going to take the data that I want to keep, the stuff that I know at least is real data, select it. I'm going to say Control X and Control V. Then I'm going to clear these two columns of data by selecting them thusly, hitting delete. That should be cleared now. It is. Now I'll just reselect this data here. Control X and Control V. And now we're back in business. I'm going to select this data set, data series. I know some of this is going to be junk, but I'm just going to go ahead and plot it all for now. And I'm going to insert a scatter plot like we did before, and there's the data. So what do we got going on here? So first we have some, obviously, I know that my sample fractured here, so this is all junk. Afterwards, I want to get rid of. And we don't start at 0, 0. We start, what we're saying here is that for a while we were applying, we were getting displacement with 0 applied load. That's physically impossible, at least in this test, right? In order to move our sample, if it's correctly placed, we have to apply a load. So that means that we were probably just cranking away before, and there was some kind of slack in the machine. So we want to get rid of that. So how are we going to do that? The first thing I'm going to do is, let me just I can click on the data and come find a data point, like let's say just this one. I'm going to right click on it, and for temporarily I'm going to add a data callout so I can see what it is. The 0.0564. So 0.0564. This right here. That makes sense. Okay. So this is we want to get rid of everything from here back. So I'm actually going. So what I'm going to do then, and let's just think about this for a second. If I zero this out, then we're still going to have, we're going to be at 0, 0, but we're going to have this little, let me just delete this guy so we can see it. We're still going to have this little bit of a curve here. And again, this is not, I'm not trying to be exact. I don't need to get into this whole experimental method question. What I'm going to do is just zero out everything from displacement from here over. So, and you'll see what happens. If I put in, so I'm going to actually, and I'm going to come and see, I'm going to make sure that I have all my, oops, wrong way. Yeah, so that's the full, there's no more data after 7. So I can say equals 0.010670, or I could have copied it. I didn't have to even put 0. I mean, equals. Anyway, it's a number there. Let me just get rid of this equals. I'm going to subtract this from this data all the way down to 0, the displacement out, and you'll see what happens over here. So I'm going to copy this cell, Control C. We've done this before. Select all this data. And I'm going to paste special. I'm going to subtract that number. And we see now we're over here basically at 0, 0. The only problem is that we have more data here than we want. So I'm going to go into my select data. I right-clicked on my chart, selected the data, and I'm going to edit it. First thing I'm going to do actually is put in a title here because I selected that at once without coming into the data series. I didn't have a title for it, so I'm going to call this stress versus strain, and I'm going to select row 20 as my first row. So if I come here to the so it's I20 to 141 and J20 to 141. And we'll see now that I'm basically at 0. And we have a sensible beginning point. Again, that would be, if it was completely accurate, it would be at 0, 0, but that's just not the way this worked in our test. Obviously, we had, for some reason, there was a little bit of force applied before any displacement. It kind of makes sense that would happen. Anyway, this is good enough for us. So what I'm going to do then is I'm just going to delete all of this above it. We don't need this. Why have it? Again, we have it in the raw data, so we can mess around with this however we want to. And I'm going to go ahead and move this up, all this data up. Let's see what happens to our graph. Maybe it'll keep it, maybe it won't. I don't know. So I'm going to Control X, Control V. And you'll see then that actually the graph updated. So if we go in here and look at and edit this data set, we're at I5 and J5 again. So we're up. Excel's really smart about updating things when you move them. So if you set things up correctly, it's really easy to work in Excel. Next thing I want to do is get rid of everything that's happening after fracture, because that's so the data on the left side over here was physically impossible. So unless we were positing a different theory of physics, we had to get rid of that. This is just misleading because our sample breaks here. So the rest of this data is meaningless. So we don't want to display meaningless data. If I change the chart type temporarily, just to just points, should be updating. Oh, we can see it here. You see that there's almost no data points past fracture anyway. It just drops down, and there's a few at the so we're cranking away, it breaks, and then we're still cranking a little bit before we turned it off. And it just quickly went to 0 force, and it's still displacing because you're cranking the auger that's moving the device. Okay, anyway, so I'm going to go back to my old display, find this data point. Now, people ask, and I think it's a very good question, isn't there a shortcut, some way of finding this data point without like just clicking on it here? I have not been able to find one. If you can, great. But I'm just going to look for 0.12866,403. 0.12866,403. Here we go. So this is the, and I'm actually going to just go ahead and select, well, for now I'm going to select that and color it so I know what I'm doing, and delete everything below it. And actually I'll just delete, of course, the displacement too. Why not? We don't need it. Delete. I don't really need this colored, so I'm going to get rid of that for now. We'll color some stuff in a second. So now we have a data set that makes sense. This is our fracture point. This is our beginning point, and we have a sensible curve in between. And we also have sensible ratios down here. So these are actually, right, this is, so 0.02, that's change in length over length. That's 0.02. That's actually 2%. Hopefully that makes sense. So if I were to change the layout of this, I want to do that. I want to change this to percentage. Now I'm going to get rid of these decimal points. I don't really care about that. Well, no, I'll leave them. No, I'll get rid of them. Okay. Let's go ahead and add. So I'm up in my chart, you should, if I've selected my chart, I should see this little green plus sign. If you don't see it, move your chart around a little bit. There's different ways to, I've seen glitches as how it doesn't show up initially, but you need to be able to see that so you can turn on your, I'm going to turn on my axis titles and my, I won't turn on my legend right now. I may need it later. All right, great. So then I'm going to go ahead and put in here, this is PCR. No, this is stress. And I could use, which is in PSI. I could use the Greek terms, the Greek letters if I wanted to. I'm just too lazy right now to do it. That I had defined over there in my terms. And this is strain. And this is, I'm going to say it's in percent. But remember, in your actual data, it's not a percentage. This is just how we're displaying it. It's because we don't want to multiply this times 100. That would not be accurate. That's changing the data. Okay. So all right, so let's start filling out our graph and our experimental data section. First thing I think we should do is do this 0.2% offset yield stress. To do that, we're going to need to get a 0.2% offset yield area zone. And remember that the 0.2% is in relation to the strain values. So we're going to shift the elastic region of this chart 0.2% to the right in the positive in the x. So how would we do that? Well, first of all, let's remember that we're seeing this entire area as a line. So we need to find whatever we consider to be most the linear portion. So I'm going to limit it because what I'm trying to do is to get a trend line that's the most accurate. So I'm going to stop it here. You'll see what I mean in a minute, I think. So that's 0.018369,000. So 0.018369,000. That's here. So I'm going to say from here to here, oops, are my is my elastic region, or this is what I'm going to use to get my 0.2% offset. So over here, I'm going to add I'm going to delete this guy. I'm going to select these rows and change it from general to number. I don't need even, and actually in the stress column, I don't need any decimal points. I'm also going to come out here and I'm going to give it a 1,000 separator to make it clearer to look at. So I've just changed the way this row is displayed. I think it's better, it makes more sense. So, and I'm saying that this highlighted area is what I need to use to get my 0.2% offset yield trend line. So how am I going to do that? If I need to shift this data, this strain data over 0.2%, I'm going to add 0.002, right? Because 0.02 would be 2%, so 0.002 is 0.2%. And I'm going to, actually, that was not exactly what I need to do. That's just making the point. That's what I'm adding. I'm going to say equals the strain plus 0.002. And then I'm just going to copy that down through this series of data points. I'm going to call this actually I've got this over here. And again, this didn't transfer that. I don't know why it doesn't do that. It does sometimes. I'm going to go ahead and give it a subscript. Okay. And this is inches per inch. Now, I'm going to plot this data set as a separate line. So if I come into my chart, right-click on it, select data, I'm going to add a data set. I'm going to call it 0.2% offset yield. The x values are these that I just created, and the y values, of course, are the stress for that zone. Okay. Now I've got this offset yield, this 2% offset yield line. I want to, I know what I'm doing. Well, actually, let's just go ahead and do it. I'm going to, if I right-click on it, I can add a trend line. I want to add a linear trend line to this. And we can see that actually this one works pretty well. It's because of the points I chose, it's actually already going through. It's intersecting my data curve. This intersection point is the 0.2% yield strength, which is one of the things we need to have in this graph. So I don't actually even have to mess with this. I could come over here and play around with sending this forward and backwards, this trend line. So if I went 0.04, I would go below 0. If I went 0.004, I don't really understand what this period is. In other words, what that's referring to. But anyway, it doesn't really matter in this case. I'm saying if you picked a smaller data set, you may have to mess with the forecasting of your trend line to make it go where you want it to go, which is through this through our data set. I'm now going to select my data series, and I'm going to come to its display characteristics and just turn it off. I don't even want to see it. And I'm going to now select my trend line and spiff it up a little bit. I'm going to make it a little bright, a little bit bigger. Yeah, that seems okay to me. And now I know essentially where my 0.2% yield strength is right here, where this trend line intersects my curve, my data curve. Okay. I think then. So I'm gonna. What else? What do I need in here? I need to. I need the slope. I need so let's just go through this. I've got my stress and my strain, which I have graphed. I haven't put the elastic region in yet. I'm going to do it at the end. I need my modulus elasticity, so let me do that right now. I'm going to select that trend line, come over here to format the trend line, and I'm going to turn on the equation for that line. And this, what is multiplied times x, is the slope of this line. So that's an easy way of doing that. I could also come in and take an average of these of the stress over strain of what I'm calling the elastic region, whatever. So this though is what I'm going to call my I'm going to say it's 4 million is my modulus elasticity. If I go in and look at this in more detail, let me see. I wonder if that'll work. If I copy this, if I paste this over here, let's see. And I get rid of the x. And I display this as, oh, see, it's not going to work. Yeah, it didn't work. That's just text. So if I really wanted to find, so that's sort of, it could be 3.94 or 3.75. I don't really care how accurate it is, but I could also then do an average of these stress over strains to get this a number that would be maybe more accurate. Okay, so I've got now my modulus of elasticity. I need my yield strength, my 2% offset yield strength, and my ultimate tensile strength. So these are all values that I can just mark in this chart. Before I do that, I do want to have a title. Did I not have that? A chart title. I'm going to name this Pasco. Why can't I name this? What the hell is going on? I don't know why it was doing that. All right, so I'm changing the title of this to, I don't know, Pasco, um, Pasco Brass 360, MTS, that's the type of machine, stress strain, whatever, some kind of title. And I'm going to go ahead and just give this a border so that I kind of, and maybe I'll make this bold, and give this some kind of border. All right. Oops, the wrong thing. I'm giving a border. Let me give this a border. And I don't want a border on this. It's the wrong color. And I want to turn the border off on that. Okay. So let's just start labeling these data points. Let's start with offset yield strength. It's about here. Let's see if I go in and find the point. Sometimes I'm zooming in. See, now it's not going to let me. I'm going to do a little trick here. I'm going to turn this into a I'm going to remember about where that is. Just get rid of that. I'm going to move that trend line. I think that's good enough. I'm going to right click on that point and make this a data label. I can now move that over here. Now I'm going to go back and just so I don't forget, turn my trend line back into a linear line so it's crossing over in the right place. I want to go ahead and format this. You could leave it that way. I don't really particularly like it like that. Also, by the way, label options. Right now, we're showing leader lines. And I'm not sure why the default here is just showing the Y value. I could make it X value, though. They're all selected because I guess I had the line selected. So this is where you make the changes to the labels, and it's the way I want it now, so I'm not going to worry about that, or I'm not going to change it anymore, but I am going to change the layout. I want the leader line to be dashed. I want it to be larger, I think 1 point, and I want it to be black. That's completely subjective, but I'm saying, you can, that's how you make those changes, right? So I selected the leader, and then I came into the paint bucket section over here, leader line options, and these are all sorts of choices I can make. Oh, actually, I'm going to give it a give the beginning of the leader line a circular arrow type, and I'm just going to leave it that size. I could make that larger if I wanted to, but actually it's too large. I'm going to choose it, so that's where I selected it. I'm going to make it smaller. To play around with these to get the one you like. I like that one personally. Okay, and I've already made colors over here for these. So this is the yield strength. It's light blue. So I'm going to select that text box and come over here and select the light blue background for it. So that's my first data point. I also want to do let's go ahead and do the yield strength. Now remember, this is the elastic region, whatever, and this is the whole reason we're doing a 2% offset yield strength is because we don't know exactly where this is changing. I'm going to say that it changes from elastic to plastic right here. Zoom in and see if I can get a little bit closer. Learn how to control mouse wheel zooms in. Let me see if I can get a little bit better. I want it right there. Okay. This data point, so if I right click on that and say add data label, I'm going to move this guy down, this guy over a little bit so that they both have a crook in their leader line. Uh, since this is the same data series, I've got the same leader line layout, so I like that. What color did I make this guy? I made it. Oh, actually, I did this wrong. So this is supposed to be blue, and the other one's green. So go to this one, make it blue, make this guy green. Maybe I want to make these bold. Maybe not, but I'm going to. Okay. Um, Now I can draw my elastic region. Um, Remember, that was just me drawing in a shape, so I'm coming into Insert. I'm going to pick this freeform scribble and just do my best to draw a fairly straight line here. I'm holding Shift, and that's not really working. This is good enough for what we're doing. Again, so we probably want to do somewhere else. I can stretch this out a little bit, maybe play around with it a little bit. The secret is to make it pretty transparent. I'm going to turn off the shape outline. No outline. And I'm going to make the shape fill. I think I made it like a light yellow over there, right? And then I'm going to make that transparent. So if I come over here to fill, and I'm still selecting this, I can change its transparency and make it pretty transparent. That'll look pretty good. Okay, now I'm going to label that, and I may have to actually so I'm going to label a couple of things. Um, I'm going to insert a line. If I hold Shift, this line should be straight. If I make so I'm going to change it. I know I'm going really fast, but remember you can stop and move this around. I'm going to make this black. I'm going to give it the same, hopefully, dotted line as the leader line above. And let me see if that worked. Yep, okay. I think I'm going to move it over just slightly. I don't know if I can actually do that since, see, there we go. And then I'm going to make its size smaller. I like that. I'm going to insert a text box now. Come up to Insert. Where is text box? Over here, text box. I'm going to call this elastic region. I'm going to call this actually I have to call it. I can't do that. I got to call it the same thing I did over here. Or maybe I'll just type it out. Make this simpler. 0.2% offset yield stress. Actually, I'm going to call it the 0.2% offset yield stress trend line. I'm going to, I can just resize this box. And I'm going to, if I select that and give it a solid fill and make that white, at least it will go over the grid lines. I wonder if I can put this, I want to put this in the middle. Yeah, there we go. That's nicer. I'm going to do the same thing here. solid fill, uh, and what I did before, maybe I'll just underline it this time. I'm going to insert a line, and I'm just going to underline my modulus elasticity. No, you know what? I don't like that. I'm going to put a box around it so that I can make it a color. So if I come back to my insert shapes, put a little box around this. Again, give it, I'm going to give it a, what's the color? Sort of an orange. This guy. Oh, and I think that might be the problem here. I don't think I can send this back. So I can't give this a color. I have to make this, in other words, it's going to be in front of that text no matter what. So if I, so go to no fill, and then I make the border of the, I'm going to get a solid line. I'm going to make it that orange color and maybe make it a little bit bigger. That's sort of labeling this modulus elasticity. What else? I need to find the UTS. And again, if I have my terms over here, I can just go straight down. What have I got so far? I did all this stuff. I've got the elastic region. I've got the modulus elasticity. I've got the yield strength. And I can even start doing this down here. So I can say, let me just copy these again. Let's just do all of these. We're going to need all of these. And see, that time it copied the subscript. So you tell me what's up with that. I don't know. This is going to be 4 million. And I'm going to call it, this is PSI. This is going to be 72 KSI, or 72, I'm just going to call it. And we'll give this KSI, which maybe I should have already done that up there, but maybe not. Doesn't matter. Because maybe we're saying that these are generic terms, so I don't give it units up here. The 2% offset is 70, let's see, 70. So I'll say 70.1 KSI. Haven't done UTS yet, or in these others. And I should go and just make this the same color, or maybe not. I mean, I don't know. This is subjective aesthetics. I don't even know what color that is. Is that gray? Maybe. Yeah, I'm not sure how those are different. Let me see. So you can come check where the other color is. Maybe these aren't the best choices, but whatevs, right? Okay. They seem a little too similar, but I don't really gonna worry about it. Okay, so now we need our ultimate tensile strength. The way I'm going to get that is I'm going to come to my stress column. I'm going to say equals max, M-A-X, and then just select the whole column. Enter. And it's 7584, which is, and I could have just looked it up. I was just showing you this little trick. 7584. So I'm going to actually give this the color of the UTS, which is gray. I'm going to delete this now. And this is 55. Let's see if we can find. That's it. I'm going to add a data label, of course. Move it up. Oops, Control Z. Nice. This is going to be gray. I should probably go back in here and label these. So this was the 70.1. So this is going to be the yield stress. It's green. The YKSI was the 72, which is interesting. I did this backwards again. No, I actually have this backwards. Got to be careful. No, that's right. So this is backwards. This is the blue one. This is the green one. No. This is the green one. This is the blue one. All right. And the elastic region is orange. We have an orange over here. Or it's kind of clear. I should probably make this yellow also then. Right. Shows us it's the elastic region. Maybe I'll make this guy light orange. It's getting a little bit confusing maybe, but that's what I have it. That's what this line is here. I think I'm not going to do that because I think that's confusing. So this is just subjective. All right, so I've got my UTS. I'm going to type that in over here. You see, I'm putting this in multiple places. That's important. 75.1 for the UTS. The fracture number is, first let me just put a label on it. And that's orange. It's bold. This also needs to be bold. Okay, what else do I need to do? So I've got my stress at fracture. That's this. I've got to type it in, 66.4. The percent elongation of fracture is just the X value right here, which is 66403. The last one, 0.13. So what color is this? This is orange, right? And this one is white for some reason. Okay. The way I'm going to mark this guy is I'm going to insert a line. If I hold shift, it will stay straight when I draw it. I'm going to I'm going to make it black. Make it the same size as the other leader lines. Give it the dotted approach, and I'm going to go ahead and give it an endpoint, just like the others. But you see, that's actually at the top. So I'll do it on both sides because that makes sense. So if I do it on the bottom, here, I can actually make this a little shorter. Holding shift to pull up on it so it'll stay straight. And then I can label this. I can draw a line and label it if I want to. But you know what? I think I'm going to. So I could label this in the same way by drawing a line, inserting it. I think this is getting long enough. Let me do a couple other things. What else do we? But this we know is what? I think it's 12.8. We can see down here, but we should look in here. It's let me. Oops, wrong way. Yeah, it's 12.8%. Okay. Then we have an analysis section we need, right? And we're almost done. we're gonna have what did I say over here? Just so I said analysis percent error. Um, Actually, this was capitalized. Yeesh, come on. Um, so UTS, I think the questions were let's do it in the other order. E and UTS. Percent error is different than percent difference. Since we have a standard, we can use percent error. We can talk about that if you don't understand, or you can look it up. So if I say the percent error difference between the published uh, number for modulus elasticity minus the R experimental divided by the published, and then I'm going to make that a percentage, 66%. And for the published UTS, 72.5 minus the R experimental divided by the published. You see now I'm going to make this percent. We get this. This is a negative percentage. Percent error is absolute. If it was percent change, we could say a negative. So I'm gonna make this an absolute by typing ABS, putting that. That should work. It didn't. I'm not sure why it doesn't let me do that. So let me. Oh, it did. You can see it's up here. I'm not sure what really happened there. Okay, I'm gonna make this bold. So we have most of what we need over here. Let's look at the actual assignment. Pretty similar. I added that down to the percent error. I've got some layout stuff I could do. I can change the look of the chart if I want to. I definitely want to truncate this, I think, to 13%. The axis at the base. That, of course, then screwed that up, so I got to move it over. That's a good thing to see, that if you the things in your chart don't always move together. Okay, let me just do one more thing, and then I'm going to call this done. There's more we could do. This didn't move with that. It actually seems like the size of it changed, which is kind of weird. Okay, I'm going to now just create my general layout. I'm going to merge all these cells. And what did I call this over here? I'm just going to copy this because I don't feel like typing it. Control C. This shows you that this is easy to do between Excel files. Control V. Make it bold. I probably made it a little bit larger over there. I don't know. Now I'm gonna. I made these little spacers. You can make these the exact same size. There's a way of formatting that. I'm not going to get all into that level of detail. But let's just do some basic layout. If I let me see how did I just want to make sure that they're somewhat similar. Okay, got it. Oops, that's the wrong one. Okay. Let's just do this. Let's select all of this. all the way down to the bottom of the data. And I'm going to give it, select all the borders. So I've got that now. I'm going to come and then select these little rows in between. Again, this is just details. You can turn this off now if you don't want to mess around with this. I'm just showing you quickly how I do these things. Merge and center. I'm going to give this a name, data. Now I'm going to just spiff all these things up a little bit by merge and centering. I can actually give this a color if I want to kind of create a transition between these different sections. I can, again, I didn't get this whole thing, I guess, so let me do that. I can start, like places where there's empty cells, sometimes I will make that, I'll merge and center it. So all this I would merge and center. And then I can come back in here. I should have, let's give that a color. Anyway, you get the idea. Then if I want to select, put a big border around all of it, which I think makes sense. I come back up here. Again, these are presets you have to set. Yours may not do this exactly. And that's pretty close to what we had. Then you could do more. I would line this up over here. Voila. Now, the last thing that you need to do, that I want you to know how to do also, and just in general, for your use of Excel, is export things. So if I just select this chart, go to File, Export, I can create a PDF. If I go to Options and make sure I'm just selecting the chart, I can say, OK. It's going to, where are we going to put this to? I'll just put it to the desktop really quickly. Publish it. Go to my desktop. And there it is. You see, sometimes there's some slight formatting errors here. Just move this over slightly, move that box over a little bit. Something you have to mess around with. But the cool thing about this is a vector graphic, so it has infinitely high resolution, basically. I can also screenshot these things and bring them into Google Slides. So that's the other option the other thing I had you do for this assignment. All right, that was very long. I hope it was helpful to somebody. And I think that's all I'm going to do. Let me know if you have any questions.